You know, we've all played around with AI that can write an email or whip up a crazy picture. And yeah, it's pretty cool. But what if I told you that's already old news? Right now, something much, much bigger is happening. We're making the leap from AI that just creates stuff to AI that can actually, well, think. Let's get into what that really means.
And that brings us to the big question, doesn't it? We know AI can nail language and images, but can it truly reason? Can it look at a brand new, complex problem and work through it step by step like a human expert would? The answer to that is changing from not really to a resounding yes, way faster than pretty much anyone thought possible.
So to really get why this is such a paradigm shift, we need to zoom out for a second. The story of AI isn't just one straight line of progress. It's more like a series of distinct ages, each one bringing a massive jump in what's possible.
Let's just quickly walk through this. Before about 2015, we had what you could call analytical AI. It was fantastic at crunching numbers for things like credit scores. Then, boom, the era we're all so familiar with, generative AI. This is the AI that mastered creating new text and images. But right now we are stepping into the third age, the age of reasoning AI. And these are a whole new breed of systems that can actually plan, fix their own mistakes, and tackle really complicated problems.
All right, so let's get into the heart of it. This new frontier, the power of reasoning. What are we actually talking about here? It's a fundamental move away from just generating content to actively solving problems.
At its core, reasoning AI is all about being goal-oriented. We're talking about AI that doesn't just give you a single impulsive answer. It can literally map out a plan, work through the steps, check its own work, and this is the crucial part. If it finds a mistake, it can go back and fix it. That's a total game changer for tasks that take hours, not just a few seconds.
And that leads to this incredibly powerful idea, summed up perfectly by OpenAI's head of reasoning, Alexander Wei. Reasoning generalizes. What he means is, we're not just teaching AI a new party trick. We're giving it a fundamental capability, a kind of meta skill that it can then apply to almost any challenge you throw at it.
And if you want proof, look no further. This is a jaw-dropper. In 2025, a single AI model did something that was supposed to be impossible. It took home the gold at the International Math Olympiad, a pure test of abstract logic. Then, the exact same model turned around and won the world's top coding competition. It didn't just learn math or coding, it learned how to solve incredibly hard problems, period.
The leap in performance is, well, it's just staggering. Take a look at this chart. On a notoriously difficult math benchmark, GPT-4o, a super powerful model in its own right, gets a respectable 42%. This new reasoning model, a perfect score, 100%. It didn't just get better, it achieved total mastery.
And it is absolutely not a one-trick pony. We see the same kind of jump in a totally different field. On a really tough real-world coding test, GPT-4o solves just under 31% of the problems. The new model, when you give it what's called thinking time, skyrockets to almost 75%. This is not an incremental improvement. This is a step change in what AI can do.
Okay, so those results are just insane, which of course leads to the obvious question, how on earth is this even possible? What's the secret sauce that unlocks this new level of thinking? Turns out it comes down to two major breakthroughs. Let's break these down, because they're the keys to the whole kingdom. The two big ideas that changed everything are reinforcement learning and something called test-time compute. You put them together, and you transform a simple pattern matcher into an active problem solver. So first up, how these models are trained. The old method, supervised learning, was basically like giving a student the answer key to a test. They get really good at knowing what a correct answer looks like, but they never actually learn why a wrong answer is wrong. Reinforcement learning is totally different. It's more like letting the student wrestle with the problem, try different things, get feedback, and actually learn from their own mistakes. The big idea with reinforcement learning is that you give the AI a clear goal, and then you just let it try stuff. When it makes a move that gets it closer to the solution, it gets a little reward, a positive signal. When it goes down a dead end, it gets a penalty. Through millions of these trial and error cycles, it literally teaches itself the best strategies for success. Now, the second big innovation is just as important, and honestly, it's pretty intuitive. You can think of it as giving the AI something we all need when we're facing a tough problem, a little bit of thinking time. The technical name for this is test-time compute. And it means that instead of just blurting out the first answer that comes to mind, the AI runs through hundreds or thousands of internal what-if scenarios.
It'll try one path, see that it leads to a dead end, and backtrack. It'll explore a different approach, weigh the pros and cons, and only after all that deliberation does it give you the final, best solution it could find.
This image of a maze is the perfect way to picture it. A traditional AI makes one impulsive dash through the maze and just hopes it finds the exit. A reasoning AI, though, is more like sending out thousands of tiny explorers down every possible path at once. It effectively maps out the entire maze to guarantee it finds the absolute best route to the solution. It trades a bit of speed for a massive gain in accuracy.
Okay, that's the theory. But what does this actually look like in the real world? How does this apply to the kind of messy, complex tasks that we used to think only a human could handle? Let's dig into a case study.
We're going to use an example that most of us would probably consider way outside the scope of AI, preparing a seriously complex tax return. This isn't just about filling in a few boxes. It's a multi-step process that involves planning, calculating, and constantly checking your work.
So, how does a reasoning agent tackle this? Well, it behaves a lot like a human accountant would. It starts by breaking down the big, scary goal, file an accurate return, into smaller, manageable chunks. It figures out which forms it needs and the right order to do them in. Then as it fills out one form, it's constantly checking those numbers against another. And here's the magic bit. If it finds a number that doesn't match up, it doesn't just keep going. It stops, identifies the mistake, and goes back to fix it. That final return only gets submitted after every single internal check passes. You can see how this same process could apply to almost anything complex.
So when you put all this together, you realize this is a really profound shift in how we should think about AI. We're moving way beyond just having a clever tool.
This is the big takeaway right here. It's a fundamental shift from AI being a passive assistant that just creates stuff for you to it becoming an active partner that can actually help you solve problems. We're moving from a tool that writes an email to a collaborator that can take a complex goal and see it all the way through to the end.
And I think this quote just nails it. What we're seeing is the blueprint for an AI that functions less like a tool you operate and more like a colleague you work with. It's something you can delegate a hard task to and trust that it will plan, execute, and self-correct to get the job done right.
And that leaves us with one final, absolutely massive question. When we have a partner that can truly reason alongside us, what problems that seemed unsolvable before are suddenly going to be within our reach? From discovering new medicines to designing revolutionary materials, what are we going to achieve?